Hello, pre-calculus. Alright, so today we are going to be graphing some exponential functions. Graphing exponentials is important because it's going to lead us into the graphs of logarithmic functions as well. So let me remind you of just a couple of things really quickly. We talked about this a little bit on Friday, if we have some kind of base to a negative power, we talked about how that's going to flip that fraction upside down or let that change sides of our fraction bar. I'm having a little bit of trouble with my autofocus here, so we'll keep trying to focus my camera as we go along here as well. Alright, so anything to a negative exponent is going to be 1 over that base. We also talked about how anything to the 0 power is 1, and you should probably know that anything to the first power is itself. So if I have 2 to the first power or 3 to the first power, it's just going to give me that number back. So that's kind of how I get started with my exponential functions. So I like to start with just kind of a table of some numbers. When you graph an exponential and a logarithm, I'm going to ask you to use 3 numbers or 3 points to graph with, and I'm going to start all of my exponential tables using those 3 numbers right there. Alright, so if I go off on the side, those are x values. If I go off on the side and I say that this is 4 to the negative 1 power, I'm going to use this rule right here and say that that's going to flip my fraction upside down, and I'm going to end up with 1/4. So I know I've got a point here at negative 1/4. Alright, on my next one, I'm going to have 4 to the 0 power, which I know anything to the 0 power is equal to 1. So I know I'm going to have a point at 0, 1. And then finally, I'm going to have 4 to the first power. So 4 to the first power I know is 4. And so my third point that I'm going to graph is 1/4. Right, so let me get all these points on here. So I've got negative 1, 1/4. That's going to be kind of little bitty right there. And 0, 1 right here. And 1, 1, 2, 3, 4 right here. And so what my exponential graph looks like is it kind of keeps going flat down there, and then it kind of curves and goes up, and it gets really big really fast with that exponential graph. And I know that it's going to flatten out right here because I'm going to take my highlighter and I'm going to put in an asymptote right there on the x-axis. So it's right there where that line that we say right there is where y is equal to 0. So y equal to 0 is my x-axis. And so I'm going to start with an asymptote right there. I don't have anything that will make that 4 become a negative y value, because even a negative exponent is just going to give me a fraction. Okay, so let me talk about domain and range just for a second on this one. So when I talk about the domain, I'm talking about my x values. This one continues to go forever this way and forever and ever and ever this way. It's going to keep getting bigger that direction. So I'm going to say that my domain is all real numbers or from negative infinity to positive infinity. Now where we're a little bit different is with my range. My range, again, I can't make that 4 become a negative y value, so my range starts right here at 0. And because of where my asymptote is, it does not include 0, so I'm going to use parentheses on that. And then it's going to go up and up and up forever, so we're going to go up into infinity. Okay. Now for my next graphs, I'm going to keep using my transformations that I've used with lots of different parent functions. So let me review that just for a minute. Right? So if we have some kind of negative on the outside in front of our function, or on the outside, I know that's going to reflect over the x-axis. And if there's a negative on the inside of my function, then I know that's going to reflect over the y-axis. We'll get a little bit of practice with both of those here in just a few minutes. Okay, I also know if I add or subtract on the inside of my function, in this case that will be on the inside of my exponential or up there in my exponent, it's going to be opposite from what you would think. So adding goes to the left and subtracting goes to the right. And adding or subtracting on the outside, in this case it'll be just right there behind our exponential, is going to go in the direction you would think. So adding goes up and subtracting goes down. And again, I'm sorry about my autofocus being funny tonight. Okay, so let's go ahead and get started with an example right here. I'm going to still use these same points that I have over here on number 1 because my base did not change. So your base is kind of what you're looking for here to see if it changed. So if my base changes to 2, then I'm going to change this to 1/2, 1, and 2. Or if my base changes to 3, I'm going to have 1/3, 1, and 3. And now in this case, this is a good example of where I'm subtracting on the inside of my function, or in the exponent. And so on the inside, when I have a minus sign right there, that means I'm going to move to the right. So I'm going to take this same parent function graph that I have right here, and I'm going to move every point to the right 2. Now because my asymptote is horizontal, that's not going to change my asymptote. So the only thing that'll change an asymptote that's on your x-axis would be if we were to move it up and down. Okay, so in this case I'm not moving up and down. I'm just moving to the right with all of my points. So I'm going to keep my asymptote right there on my x-axis, or right there where y is equal to 0. Okay, but I am going to take each of my points over here and I'm going to move them to the right 2. So let me start at -1, 1/4, and I'm going to take that point and I'm going to move it to the right 2. Okay, it's not just exactly on 1/4, but that's okay. All right, then for my table on number 1, I'm going to take the point 0, 1. I'm going to move it to the right 2. And finally, I had the point 1, 1, 2, 3, 4, and I'm going to move it to the right 2. So my new function will look like this. And again, it'll get really close to that asymptote without actually touching or crossing it. I know it's a little bit hard to see it right there, but it gets really close to that asymptote without touching or crossing it, and then it gets really big really fast. Okay, let's jump down to number 3. All right, on number 3, this is a good example of where I'm subtracting on the outside of my function. I still have this same base, so I'm still going to use these 3 points right here, but then I'm subtracting on the outside of my function. That's going to make everything move down 5. Okay, now a down 5 move is going to move my asymptote. I like to go ahead and kind of do that first. So I'm going to go down 1, 2, 3, 4, 5. And there's my new asymptote right there. 1, 2, 3, 4, 5, 2 numbers. Alright, so there's my down 5. And again, I'm going to take these same 3 points. So I'm going to go over to -1, 1/4. And I'm going to move down 1, 2, 3, 4, 5. And then I'm going to do 0, 1. So 0, 1. And I'm going to move down 1, 2, 3, 4, 5. And I'm going to go 1, 4, 2, 3, 4. And I'm going to move down 1, 2, 3, 4, 5. And there's my new exponential. And again, it just gets really big really fast and flattens out along that asymptote right there. Okay, finally, to go along with my base of 4, I've got a negative sign that is inside my function. It's inside my exponent. So when I have that, I know that I'm going to have a reflection over the y-axis. Okay, so I'm going to take this graph that I've had. There we go. All right, I'm going to take this graph that I've had and I'm going to reflect it over the y-axis. So this time, rather than my graph being here, it's going to flip over this direction and be here. Okay, now it is not going to affect my asymptote. A reflection does not affect your asymptote. So the only thing that affects a horizontal asymptote will be a move up and down. The only thing that affects a horizontal is a move up and down. Okay, so I'm going to start with my first point from my table over here on number 1. You can't quite see it on there. There we go. This point right here, I'm going to go to -1, 1/4. And then I'm going to reflect it over the y-axis. So that's going to put it at 1, 1/4 right here. Okay, now 0, 1 is on the y-axis, so I can't reflect it. It's going to stay where it is. And then I've got the point 1, 1, 2, 3, 4 that I'm going to reflect over the y-axis, which is going to put me right here at -1, 4. So basically, we're changing the signs of our x values there. All right, and this time I'm going to go towards my asymptote on this side. And I'm going to go up quickly over here on this side. Okay, so again, everything that we have had that goes this direction has flipped, and now it's going to go this direction. Okay, the last type of exponential we're going to talk about is e. And let me help you find some values of e first. All right, so e is just a number. E is kind of a number that's like pi. All right, so I'm going to go over here to my calculator, and I'm just going to do e to the first power in my calculator. So clear it out, e to the first power. Not sure what my calculator's doing. Hang on, sorry. E to the first power. Well, my calculator won't do it right now, but e to the first power is like 2.7-ish, somewhere kind of right around 2.7. It's like 2.718. Again, it's a little bit like pi, and e is just the opposite of a natural log, and we're going to use that e and that natural log value a lot. All right, let me do 0. So we said we were going to use -1, 0, and 1 for our x values. So e to the 0 power, just like anything to the 0 power, is equal to 1. Okay, so anything to the 0 power is equal to 1. And then e to the -1 power, to my y values, is going to be 1 over e, which comes out to be approximately like 0.36. So it's going to be just kind of a little bitty decimal. Okay, now e has the same asymptote as my other exponentials, so I'm going to still have this horizontal asymptote right here on the x-axis. So that's not going to change when I start to work with e. What's going to change is my y values over here. Okay, and again, we just use e as the opposite of a natural log. All right, so let me go to -1, and 0.36 is right here. And 0 is going to give me 0, 1, just like it did with my base of 4 up there. And then this is going to give me 1, and 1, 2.7 puts me right there. And that's what my e graph looks like. And again, it looks a lot like my graph of 4 to the x, except that this time we're working with that number of e, which is like 2.7. Okay, so what I'd like for you to do is pause the video. I'm going to pause my video as well. So pause your video. Let me get that back where it's focused. And try number 6, 7, and 8. So the same rules up above apply to these as well. So try 6, 7, and 8 with their transformations, and then we'll come back together and check. Okay, hopefully you had a minute to try 6, 7, and 8. So if you haven't, pause your video and try those. So here's what the reflection over y would look like. Again, sorry about that focus right there. So here's what the reflection over y would look like. So rather than going to the left one and up 0.36, I went to the right one and up 0.36. And then here's my left one with the 2.7 right there. And then that point that's on the y-axis will stay on the y-axis. And again, there's no effect on my asymptote on that one. It's going to stay exactly where it is. Okay, now on number 7, you did have something happen to your asymptote. With this one, we needed to move to the left 5 for my what's inside, opposite from what you would think, and then my down 7 for my -7 out here on the outside. And that down 7 is going to take that asymptote off the x-axis, and it's going to move it down here to this -7 line right here. All right, so then I took every point, so like I took 0, 1, and I moved it to the left 5 and down 7. And so there's my new 0, 1 point right there. And then finally, on number 8, I needed to reflect over the x-axis. So again, that reflection does not have an effect on my asymptote. The only thing that affects a horizontal asymptote is a move up or down. With a reflection, I'm just going to take every point. So where I did have -1.36, I went up 0.36. Instead of going up, I went down. And instead of going 0, up 1, I went down 1. And instead of going over 1, up 2.7, I went down 2.7. So again, it's very similar reflection and transformations that you did with all of your other parent functions. Okay, flip over on the back side for me. and it asks us some questions about that e to the x graph. So let me draw a little picture, a little sketch of that e to the x graph that we can refer to again really quickly. So we know that we've got an asymptote, a horizontal asymptote, on the x-axis right here. And then I know I've got a point at -1.36 right here, and 0, 1 right here, and 1 with 2.7 right there. So here's my graph of e to the x. Okay, so again, same graph of e to the x that we did on the front side. All right, so let's start with our domain. Domain is our x values. I keep going forever to the left and forever to the right. So my domain will still be all real numbers, or in our case, negative infinity to positive infinity. All right, just like the other exponential that we talked about a minute ago on number 1, my range, I can't do anything to make this thing negative. So I'm going to say that my range starts at 0 but does not touch it because of that asymptote and goes up to infinity. All right, it asked me to name 3 points, so I can just name the 3 points on there. I'm going to name them as -1 with 1 over e, and I'm going to name 0, 1, and I'm going to name 1e. So rather than putting in those decimal approximations, I'm going to call this point e, or this y value e, and I'm going to call this y value e to the -1, or 1 over e. All right, ask, are there any x-intercepts on the graph? X-intercepts would be if it crosses or touches the x-axis. We know that it does not because there's an asymptote there, so there are no x-intercepts. And then I do have a y-intercept. It crosses or touches my y-axis at this point right here, which is at 0, 1. And again, I'm sorry about my autofocus being so crazy. Okay, flip over, and we're going to take a look tonight also at the graphs of our logarithmic functions. Okay, so let me give you a few minutes to read through these directions right here. This will give you a lot of information about logarithms. We haven't worked a lot with logarithms just yet, so it gives you some information about what the log with a base is, or a log to the first power, 0 power, all of those things. So pause the video for just a minute and read through those directions on 1 through 4. Okay, if you haven't had a chance to pause the video, please do and read those 1 through 4. And I'm going to jump down here and get started. Now, there's a couple of different ways to graph a logarithm. I like to graph a logarithm by thinking about it as being the inverse of my exponential. Okay, so we just talked about those exponentials. And with my exponential, I'm going to start with working with 4 to the x because 4 is the base that I have on this logarithm. Okay, if you're working with a base of 2, then work with 2 to the x. Or if you're working with a base of 3, work with 3 to the x. Okay, so let me start with just 4 to the x, and we just said that 4 to the -1 power is 1/4, and 4 to the 0 power is 1, and 4 to the first power is 4. So I'm going to take these x values of -1, 0, and 1 and plug them in. And then know anything to the 0 power is 1, and negative flips my fraction upside down, and 4 to the first power is just 4. So with my logarithm, what I'm going to do, because it's the inverse, is I'm going to switch my x's and my y's. So now I'm going to have the point 1/4, -1, 1, 0, and 4, 1. Okay, so again, it's just an inverse. And we talked earlier in the year about an inverse. It's just a switching of x and y. So I took my x, y columns here, and I flipped them over to get these over here. Okay, so let me go take a look at that graph. So I've got 1/4, -1. I've got 1, 0. And I've got 1, 2, 3, 4, 1 right there. Okay, so this is what this graph looks like. And I know it's also going to flatten out. And with my exponential, I had an asymptote on the x-axis. So if I switch my x's and my y's, now I know that I have an exponential right here on my y-axis. So again, just like everything else switched, my asymptote on my x and my y-axis switch as well. So now I've got a vertical asymptote on the y-axis, or on what we call x equals 0. Let me get that autofocus again. Okay. With logarithms, our rules for our transformations stay the same. So if we are adding on the inside, like down here on number 3, I'm going to move to the right or to the left. If I'm adding on the outside, I'm going to move up or down. A negative on the inside makes it reflect over the y-axis. A negative out here in front would make it reflect over the x-axis. Okay, so again, pause your video and give numbers 2, 3, and 4 a try. Okay, hopefully you had a minute to finish up 2, 3, and 4. So you probably also found out, let me move this out of the way, you probably also found out that that vertical asymptote on this one is not going to be affected by a move up or down. This time a vertical asymptote is only going to be affected by a move to the left or to the right. That's the only time that something affects this vertical asymptote. Okay, so move up 3, my vertical asymptote is going to stay where it is. I just took each point. I'm still working with a base of 4. So I took each point from my table over here, and I moved each point up 3. So for example, I went over to 1, 0, and I moved it up 1, 2, 3. And I did that with all 3 points. Again, 3 points is plenty to draw one of these graphs. Okay, on number 3, I did have a move to the left. This was inside my function, so it's going to be opposite from what you would think. And I'm going to move to the left. So I took my vertical asymptote, I moved it over here to the left 3. And then I did the same thing I did on number 2, but I went to the left. So I took each point, for example, 1, 0, and I moved it to the left 1, 2, 3. And there's my new point right there. So I did that with all 3 points off of my table right up here. Again, I was still working with that base of 4. So if this changes again like to a 2, then this is going to change to 1/2, 1, and 2. So watch out for that base changing numbers on you. Okay, and then finally on number 4, I was reflecting over the y-axis this time because it's being multiplied on the inside of my function. So over the y-axis, my vertical asymptote is not going to change, and I truly just did a reflection across my asymptote or across that y-axis. So let me look at the point 4, 1, 2, 3, 4, 1 is 4 away from my y-axis here. So I reflected over, and now I'm 4 away from my y-axis over here. I did that with all 3 points again from that same table. Okay, let me help you get started on the back side. So flip over for me. And like I said a little while ago, a natural log is just the opposite of e, or e is the opposite of a natural log, or the inverse of it. Okay, so this time to make my original table, I'm going to be using e to the x. I didn't leave myself enough room up there. Okay, so a natural log is just a log with a base of e. Let me write that down. Log with a base of e of x. That's what a natural log is. Okay, so I'm going to use the same technique that I used earlier, and I'm going to go ahead and find all of my values for my table with e. So we said a little bit earlier that's like 0.36. Anything to the 0 power is 1, and this would be e to the first power, which is about 2.7-ish. Okay, so to graph my log with that base, I'm going to find my inverse by switching my x and my y. So now I'll have 0.36 negative 1, I'll have 1, 0, and I'll have 2.71. Okay, so my asymptote's not going to change. My asymptote's still going to be a vertical asymptote right here on my y-axis. And again, even no matter what your base number is on these logarithms, you're still going to have that same vertical asymptote. The only thing that will change that will be a move to the left or a move to the right. All right, so let me graph my points. So 0.36 negative 1 is about right there. It doesn't have to be exact. 1, 0 is right here. And 2.71 is right here. So there's my graph of my natural log. We're going to use natural logs a lot when we get into solving equations next week. Okay, so again, same transformations apply. So give 6, 7, and 8 a try. Pause the video and give those a try. Okay, take a minute to check yours. So on number 6, we were doing a reflection over the y-axis. That will not affect my asymptote. It's going to stay where it is. It does give me something, however, to reflect across, which is kind of nice. So let me do 1 point. Let's say that I'm at 1, 0, so I reflected it across, and now I'm at negative 1, 0. Focus that again a little bit better. Okay, let's jump over here to number 7. So, focus. Number 7, we had a reflection over the x-axis that will also not affect the asymptote. It is just going to flip everything upside down. So over the x-axis, my 0.10 will not change. It's going to stay where it is, but where I had 0.36 negative 1, I now have a positive 1. And 2.7 positive 1 is now a negative 1. And it just kind of draws upside down right there. Okay, and then finally on number 8, again, that move up is not going to affect my asymptote. It's going to stay right there where it is. I just took each point, for example, 1, 0, and I moved it up 1, 2, 3. And again, those same 3 points just all moved up 3. Okay, last one. Number 9 asked me some questions about my natural log graph. Let me draw that a little bit bigger so that we can use it right here. We just drew it up there on number 5. So just reusing number 5, I have a vertical asymptote right there on my axis. I'm going to go over here. I'm going to go to 0.36, negative 1, and 1, 0, and 2.71. So again, the same 3 points that I used up there on number 5 because we're working with that natural log graph. It looks a little bit like that. It's a little bit easier to see on this one because my graph isn't quite so small. Okay, so when we talk about logarithms, domain is what's going to be affected. That was in one of those rules at the very beginning of this worksheet on the front side. Okay, so with my domain, this time my domain is what's being affected. I cannot use anything that's negative, so this is going to go from 0 over to infinity with parentheses because we're not touching 0 because that's where my asymptote is. Let me try to get to focus. There we go. Okay, so parentheses because we're not really touching 0. Okay, my range, however, this graph goes down and down and down forever and up and up and up forever. So this time my range is going to be all real numbers. So we talked about logs and exponentials being inverses of each other, and what that did was that switched my domain and my range. All right, my asymptote is on the y-axis. We call that the x equals 0 line. So please don't just write y-axis. Make sure you know the line. Right, they asked me if we have any x-intercepts. This time we do. Right here it crosses the x-axis at the point 1, 0, right here. But this time it does not cross the y-axis. So hopefully you're noticing that everything x and y is switching on this. And then it asked me to name 2 other points on this graph. So again, I'm going to write these a little more algebraically. So I'm going to write 1 over e with negative 1. That's this one right here. And then over here, this 2.78 is e to the first power, so e1 would be my other 2 points. Okay, so in your homework packet, we need to try worksheets 2 and 3. I'm going to take questions from those tomorrow in class and give you some time to work on them tomorrow in class. Okay, so it's a lot of homework tonight. You don't need to finish all of it. You will have some time tomorrow in class. I hope y'all have a great day.